This is your video on the law of sines and the law of cosines. We started talking about these in class, so we're going to continue that discussion now. We'll be doing notes on a flashcard, so you'll need a flashcard, and some examples from your packet, so you'll need that as well. All right, so we're going to start with the flashcard, and we're going to call this the law of sines and the law of cosines, and this is flashcard number 44. Okay, we're going to start by drawing an oblique triangle. And so the only thing we need to make sure is this, these things don't just pertain to right triangles anymore. So we want to make sure that when we draw pictures, we just make sure we look like it's as much of a generic triangle as possible. So just draw a triangle, kind of like that. It's good to try to make it scalene just so that you don't think that it would only work for other kinds of triangles. We're going to label the angles A, B, and C. Angles get labeled with capital letters. Okay, so A, B, and C. And then the sides get labeled with the lowercase letters across from each angle. So across from capital angle A is lowercase side A. Across from angle B is side B. And across from angle C is side C. Okay, so that's how we're going to label the triangle, and it's going to be important that it's labeled correctly so that we understand what these formulas are going to be. So we're going to start with the law of sines formula. And for the flashcard, we're really just going to write down the formulas, and then the examples will be in the packet, okay? So the law of sines tells us that the sine of angle A over side A can equal the sine of angle B over side B, or the sine of angle C over side C. So this is a proportion, and you can use any two of these three parts in the proportion as long as angle A and side A are together, angle B and side B, angle C and side C. The other thing that you can see, which you might see once in a while, is to have the side on top and the sine on bottom. And if you flipped both of the fractions or all three of the fractions, then that proportion would work as well. Okay, so it really doesn't matter if you have the sine of A on top or side A on top and the sine of A on the bottom, as long as you're consistent with your proportion, okay? Now, in order to solve a problem with the law of sines, you want to keep in mind this involves two sides and two angles, and they do have to be corresponding, okay? Now, if you're solving for something, obviously one of those four pieces of information is going to be missing, but you need to make sure that you have the correct information to set up the law of sines. So you need to have two sides and two angles. Probably three of them are known and one is missing. And you have to make sure that you have the corresponding information to do this method, the law of sines. Okay, I will show you an example of how that works in a minute. Let's just finish up the flashcards. So we're going to talk about the law of cosines. And for the law of cosines, it's much more involved, and there's technically three different versions of the equation. You really don't have to know all three. As long as you know one, you're totally fine, but they're pretty much just derivations of each other. They're just kind of where sides change. So we can say that a squared is equal to b squared plus c squared minus 2bc cosine of a. Okay, so any side A squared is equal to the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle that corresponds to the side that's over here. And that's the most important thing to remember, is that if you are looking for side A, then you're worried about cosine of A. Okay, now all the other versions of this just put different letters in different places. So, and if I'm looking for side B instead of a squared, we can say b squared equals a squared plus c squared minus 2, and then it's always the product of those two, so ac, cosine of the angle that corresponds with this, so cosine of capital B. Okay, and the third version is just for side C. So c squared is equal to a squared plus b squared minus 2ab cosine of C, okay? Same exact equation 3 times. It just depends on what information you have as to what side you would put out here. And it really doesn't even matter if you just know this first one, then you can always call the side that you're looking for or the angle that you're looking for A, and then you can always use this top equation, okay? So don't worry about memorizing all the different versions of this equation, okay? For the law of cosines, you are involving 3 sides and 1 angle. Okay, so if you only know 1 angle measure, hopefully you know 2 of the side measures and you can find the other side. Or if you know all 3 sides, then you can find the measure of 1 of the angles using the law of cosines. Okay, so let's put this to use and let's open our packet to page 20. Okay, so on page 20, we're going to do 2 examples that involve the law of sines. Let's start with number 1. We have triangle ABC. Angle B is 82, and that's labeled. Angle C is 36, and that's labeled. And side A is 15. Again, notice this is not a right triangle, so obviously if it's not a right triangle, SOHCAHTOA would not work. And so that's where the law of sines and cosines come in very handy. We're going to find the length of B to the nearest tenth of a meter. So I'm going to go to angle B, and across from it I'm going to label side B. Okay, now I know side A, but I do not know angle A. And I know angle C, but I do not know side C. So the law of sines actually won't work right now with the information we have. But the good news is we can find angle A easily by adding up these 2 angles and subtracting from 180. So 82 plus 36, make sure my math is right here, we're going to get 118. And then we're going to subtract that from 180. So 180 minus 118, and of course you can use a calculator to do this, would be a 2 there and a 6. So we have a 62-degree angle here. Okay, so if you know 2 angles, not a bad idea to just find the third no matter what. So we're going to use the law of sines. So I'm going to say the sine of angle A over side A, since I now know both of those, could equal the sine of angle B over side B, which is what they asked us to find, was the length of B. Okay, so now we just fill in. So the sine of 62 over 15, that's side A, equals the sine of 82 over B, because we do not know side B. Now, you don't want to touch your calculator until you get to the very end. So you're going to figure out what B is in terms of everything and then type it into your calculator. So we're going to cross multiply. So now I have B times the sine of 62 is equal to 15 times the sine of 82. And come over here to get B alone, we're going to divide by the sine of 62. And now you can go to your calculator, and this is what you'll type into your calculator to get an answer for B. Okay, so let me show you how that would look. I know a lot of you don't have access to calculators at home, so take a quick look here. And we would have, I'm going to make a fraction, control, divide. And on top I'm going to put 15 sine 82. And on bottom I'm going to put sine of 62. And that gives me 16.8232. Notice I am in degrees, and you want to always double check that before you do anything else, but I'm good there. So to the nearest tenth, they asked us, this would be 16.8. Okay, so let's jot that down here. B would be 16.8 meters. Okay, and that's how the law of sines works. The tricky part probably is getting to the point where you're using all of the trig functions together and then typing it in at the end. Okay, so that's something that we might need to work on a little bit if you're struggling at all. Now let's go down to number 4. I'll switch to blue here. So for number 4, we're not given a diagram here. We've got triangle PQR. Angle P is 65, side P is 18, side Q is 22. We're going to solve the triangle. That means to find all missing sides and all missing angles, okay? Now, might be helpful to draw a picture. You might not need to, but I'm going to. Just going to squeeze it kind of in the corner here. So I have triangle PQR, Angle P is 65, side P is 18, and side Q is 22. Now, if I knew two angles, I could easily find the third, but I don't. So I'm going to find a missing angle, and then I'll be able to find the third. So I'm going to go ahead and look for angle Q, because the side across from Q is known, and angle P and side P are both known. So now I can say that the sine of P over side P is equal to the sine of Q over side Q. So the sine of 65, that's angle P, over 18, which is the measure of that side, equals the sine of Q, since I don't know it, over 22, which is the measure of side Q. Okay, cross multiply. 18 times the sine of Q is equal to 22 times the sine of 65. And we need to divide this time by 18. And that's not going to be our answer, so we're not going to the calculator yet, because the sine of Q is equal to 22 times the sine of 65 over 18. And now we need to do the inverse sine. I'm going to continue this down here. We actually probably won't do question 5, so you don't have to worry about that. So angle Q is the inverse sine of this fraction, 22 sine of 65 over 18. Okay, so you want to get to the point where you have what you're looking for alone, and now you can go ahead and use your calculator. Now, something interesting is going to happen here, so watch this. So let's get that out of the way. Let's go to the calculator. And we had inverse sine of, and I'm going to do control divide to get a fraction. It was 22 sine of 65 over 18. And we have an undefined value. Okay, now we talked briefly about this in class, but what happens is you have, I'm just going to type this in real quick, 22 times the sine of 65, over 18, is 1.10771. If you think of that as a fraction, it's going to be an improper fraction, okay, where the bigger number is on the top. So what we're saying is this number is bigger than 18, but remember, sine is opposite over hypotenuse. We cannot have an opposite side larger than the hypotenuse. Even though this is not a right triangle, it's still calculating it according to what the ratios are in right triangles. And so because this ratio is bigger than 1, there is no angle that has a sine of this. And that doesn't mean that we did anything wrong. That actually means that a triangle with the given dimensions cannot exist, okay? So angle Q, I'm going to put DNE for does not exist. We did that in class once before. And so what that means about this problem is a triangle does not exist with these measures. Okay, and you would just write something along those lines just to explain that you realized this problem is actually not possible to solve, okay? So you could say not a possible triangle or something like that, okay? But that's the process you would use to find a missing angle, and so if we had gotten an angle measure, we would have known it. And if we get that error, we want to double check and make sure we did it right, and then that just means it doesn't exist. So that is how you use the law of sines to find, in example 1, a missing side. In example 4, we were looking for a missing angle. Okay, now we're going to do one of each with the law of cosines. Okay, so we're going to go ahead and flip the page. Got to go a couple pages here. Okay, so this is page 25, and we're going to do 2 practice examples with the law of cosines. I'm going to go ahead and write down that first version of the law of cosines here so that I have it to look at. Of course, if you have your flashcard nearby, you're not going to need that there, but it's always good to jot it down when you're first using it. Okay, so in this example, number 1, we have triangle ABC. The measure of angle A is 40, side B is 16, and side C is 20. And we want to find A to the nearest integer. So remember, the law of cosines involves 3 sides and an angle. And that's what we have here. We know 2 of the sides and an angle, and we're looking for the third side. So I'm going to go ahead and stick with the version I have above because I have side A missing. Okay, and so what we're going to do here is substitute what we know. We do not know side A, so A squared equals. Side B is 16, so 16 squared. Side C is 20, so 20 squared. Minus, now we plug those in again, so 2 times 16 times 20 times the cosine of angle A, which is 40. Okay, now if you want to do this in a really quick and easy way in your calculator, instead of typing this in, you're going to end up with a decimal approximation, which can get a little bit tricky. We're just going to go ahead and take the square root, because the square root of A squared is A, of this whole thing, and then you can just go ahead and type that whole thing with the square root into your calculator. Let me show you what that looks like here. And so we're going to do a square root, and then we're going to type all this stuff in. So we had 16 squared, plus we had, oops, out of the exponent there, plus we had 20 squared, minus 2 times 16 times 20 times the cosine of 40. Okay, and of course these are coming out as decimals because we know that our trig ratios come out to be decimals, and this said to the nearest integer, so the answer here is going to be 13. Okay, so in this example, side A measures 13, and we weren't given units, so we'll just call it 13. Okay, now if you wanted to type things into your calculator previous to that and not do the whole giant thing, that's okay, but you need to make sure you round out to like at least 4 decimal places. And so sometimes just easier to do the square root right there. Okay, let's look at number 4. Okay, no, not number 4, number 2, sorry. I want to do one where we're looking for an angle here. So number 2, we're given triangle ABC. The sides are 11, 16, and 20. Find the measure of the largest angle to the nearest degree. So since we know 3 sides, we're able to find an angle using those 3 sides. Let's figure out first where the largest angle is going to be. And do you remember how to locate the largest angle of a triangle? And the way we do that is we look for the angle that's across from the longest side. And so in this case, angle B is going to be the angle that we're looking for. I'll just put an X in there because it's across from the longest side of 20. Okay, now because we're looking for angle B, the 20 is side B, and then this will be A and this will be C, and the order of those actually doesn't matter, but since the triangle is labeled with the A and the C, I'll use those like that. So we might want to switch the version of the law of cosines that we're using. So we can do that to B squared equals A squared plus C squared minus 2AC cosine of B. Now if you don't memorize all those different versions, the biggest thing for you to remember is that this side has to match this angle. So the very first thing and the very last thing have to match, and then in the middle you just have the other 2 things, okay? So if you're not using the different versions, that's fine. So we actually know side B this time, so that's 20 squared equals, and side A is 11, so 11 squared, and side C is 16, so 16 squared, minus 2 times 11 times 16, so I plug in A and C, times the cosine of an angle B is what we're looking for. You can always replace that with an X if you want. And so this time, because we're looking for the thing that's over here, it's not going to be as super simple as just typing in a square root, but we can figure these things out. Like 20 squared is 400, and 11 squared is 121, and 16 squared, maybe I should know off the top of my head, but I'm just going to check it in my calculator real quick because I'm not super confident. You guys probably know it. 256. Okay, so 16 squared is, back here, sorry, 256. Okay, minus, now let's do 2 times 11 times 16. Again, I'm going to go back to my calculator. So 2 times 11 times 16 is 352. Sorry for the back and forth here. So minus 352 cosine of B. Okay, now we want to get cosine B alone. So these 121 and 256, we can add those together. See if I can do that real quick. So we're going to end up with 7, so 377. And then we can go ahead and subtract that on both sides, which is going to give us 23. So 23 equals negative 352 times the cosine of b. We're going to divide by negative 352. Don't get nervous that there's a negative here. We're going to divide by negative 352. And so, we're in another room here, the cosine of b is equal to 23 over negative 352, or you can make that whole fraction negative. And then we're going to take the inverse cosine of that fraction. Now, here's why I told you not to worry about the negative. Watch what happens. Inverse cosine of, again, I like to put a fraction in. You don't have to when it's just two numbers, but 23 over negative 352. And look at that, we were given an angle measure. So there are possibilities where we have negatives, and what it ends up doing is just finding the supplement of the angle that you get when there's a negative, okay? So this turns out to be, to the nearest degree, 94 degrees. Okay, so angle B is equal to 94 degrees. And that's how you find an angle using the law of cosines, okay? So one finding a side, one finding an angle. We'll do more practice with this in class, and I will see you then.